It's going to be a panel about space technology on Earth.
Maybe. We'll see what happens, but that's the goal.
These
Welcome.
chairs have a lot of space.
Yeah. There's a lot of space.
There is a lot of space, yeah. There's a lot of space to cover, you could say. Yeah. So, yeah, I mean, the topic is how can we use space technologies here on Earth? And I think that's a big question. Most of the panel discussions are. So I thought I would start with something fundamental again, which is how do we see space tech being used today? And yeah, from any one of you, maybe in your particular, what's your favorite usage of space tech that you've seen?
Oh my. I just gave a talk, and there's over 2,000 technologies that NASA actually provides the public that everybody lives with.
Mm-hmm.
And a favorite, it's difficult. Every marketplace has technology that space is inspired. So if everybody has a cell phone, the camera that's in the cell phone is NASA technology.
Really?
The computer on a chip. So that's probably one of the most used technologies. LEDs, light-emitting diodes, that was invented for NASA on the space station. So those are two. I don't want to go on. I could go on forever, but.
Yeah, I think like space. So I just said. So how many people were here in any of our talks earlier today? Just so we know how much to recap and how much not to. Okay. So I've got this line: space technology already underpins all of our major economic sectors and all corners of society, but it's so far up the supply chain that we don't really think about it. We don't really realize it. So we could be here all day talking about just what should we use it on? It's like, well, we already are.
Yeah.
I think in terms of like my favorite use, I don't know if I have a favorite use, but I think the one that's most interesting to me is Pokemon Go.
Pokemon Go.
Pokemon Go. Because I just find that when you think about it in the context, there's this amazing, incredibly expensive US Air Force asset, the Global Positioning System. It was designed to be like one of the most valuable military assets in history, and we use it for playing a video game on our phones. That's just absolutely ludicrous, really, when you think about it. So I find that just such a really weird concept.
So I guess to be devil's advocate about the actual theme of this discussion, I don't really see space technology not being used for Earth. Mm-hmm. It's all about Earth, or all about humanity, really. But okay, so having said that, maybe I guess the most important thing today is really remote sensing for climate, for weather, disaster relief, like monitoring every single thing on agriculture. Like everything it touches, kind of a lot of the industries that we have today, and we always take these things for granted. There's a lot of spin-offs that have been basically created, from Kevlar to Velcro. Those were all originally, or smoke detectors, those were originally done for space, but then spin off to a lot of terrestrial applications as well. So I'll stop there for now.
I echo everything that the panelists have already said, and there's two things that make me excited for the future. One is related to remote sensing. So we've had satellites that are up taking pictures of the Earth for decades now, but really the commercialization of that has just started, and it's still very new. And we're not only taking pictures in red, green, blue and the visible spectrum, but we're going into synthetic aperture radar that can see through those clouds that used to obscure images. We can see hyperspectral imaging. Yeah. So I think we're at the point where we're starting to introduce these new technologies, and it's not space people who are going to build the applications for those pictures. They're going to build the satellites and get the pictures, but the technology and what comes out of that is actually going to come from the image processing and focusing on maritime or agriculture or disaster relief. So I'm very excited. I feel like we're taking these pictures and we don't even know how ubiquitous having imagery from space every day is going to be in 5 years from now. The other thing I'm excited about is this connecting remote areas that haven't been connected before through satellite communication systems that are being developed now. When O3b was launched a couple of years ago, it connected islands that have never been connected before, where their tourism was still decades behind, where you would have to make a call and see if there was a hotel reservation. They weren't able to advertise on the internet because it was a remote island that didn't have fiber yet. So I think as we start to connect the unconnected parts of the world and bring the internet to places that haven't been connected before, I'm very excited with what comes out of that.
I just want to add like sort of one
please
thing
do,
in addition as well. I think one of the, if there's a word that you keep hearing, and that word is humanity, that's not by accident. I think that it's not just because we're trying to make space seem even more nebulous, pardon the pun. We'll have space puns aplenty, so just ignore them. Nebulous than it already is. It's because space has never actually been about space. Space has always actually been about us as humans, whether we are here on Earth and how it can benefit us, and as we've seen so many examples of how it has, but also as we look out into the universe, it's really again about us. Can we explore what sort of opportunities will arise if we start to look beyond, as I've been saying before, the boundaries of our pale blue dot?
Actually, that's the good thing about robots too. Robots are really good at simulation, and sure, software and robotics are going to do some of our tasks, but they're not good at being. And so, in fact, they're going to help us be more human, and hopefully people will start to be more creative, ethics, all these things that are human traits. Exploration is a human trait. The fact that we go into space, I don't know any robot that would want to, unless we tell it to.
Yeah, I was going to say, we do make them do it.
But, so when you have AI, one of the speakers yesterday, was saying that you have the U.S. and China, and their cultures are actually driving AI. And the European Union has their own culture. And so, you need to kind of control those aspects of technology. You can't be controlled by them.
Yeah.
And so, being human is really important.
Yeah, it's an interesting one. So I ran an event back in Melbourne in Australia about 4 weeks ago now. And one of the special guest speakers I brought in was actually she describes herself as a technology ethicist. And she came because she's very interested in space, and so she said, well, she's also a space ethicist. And it was really fascinating listening to her talk, because we all, I guess, like especially with autonomous vehicles and all these sort of technologies and social media, we're starting to think more and more about the ethics of how does this technology impact us. You can't just sort of put a technology out into society and expect that nothing good or bad will happen. There will be impacts there. But just thinking about the ethics behind space, and what does it mean for us to be human? What does it mean for us to go and colonize or settle or create habitats, or all these different things? There was a question that was asked in my session that I just came from by someone. I didn't ask your name. Are you in here? You asked about space law. No. So we gave an example about orbital insight and planets, Planet Labs, planet.com. Using Earth observation data and monitoring, where should the limitations of that be, where we're taking too much information that may not necessarily be what we should be allowed to take. So it's a really, it's a black hole. We could really go, it's fascinating. So if you haven't thought about that already, spend 6 hours just thinking about all the different implications, because we need to think about that.
Well, you know about law because you're starting something in New Zealand, and they had to make a whole bunch of laws, didn't they?
So, it is interesting that all of these technologies are happening fairly quickly, but space law and space policy is kind of like lagging behind. So today we have, from the UN Outer Space Treaty, which of course has been drawn up decades ago.
67.
And we're now in a new era. And all of these questions about, now that we're looking at mining the moon or mining asteroids or going out there, who owns what? All of these things are things that those people who actually created the laws before have not really thought about. And that's where kind of like, you think about the whose ethics and whose moral standard are we actually looking at? Is it the UN or the nation states, or is
the
it
US or China, or
the companies who are actually going? And that's a big debate. I don't even know what the the answer to that yet, but I think those are things that needs to be looked at now, because all of these things are coming pretty soon, and
Super fast.
yeah, super fast.
It's crazy. I think so. For those of you who don't know, there's this thing called the Outer Space Treaty. Does anyone actually remember the whole name for that? The 13-word, the celestial bodies, and anyway, look up the Outer Space Treaty.
Yeah,
It's got a really cool name for like a piece of law. It's one of the coolest things you can think of. Anyway, so it was developed in 1967 and it hasn't really changed much since. And it's interesting. So if you happen to be interested in politics or law or philosophy, this is where you can actually get interested in space too, because it came about when Soviet Russia and the US basically said, look, we need to put limitations on essentially how we're going to militarize space. So we're going to call it this really nice thing, and we're going to talk about that, but that's really about limitations of how we should use space. And it's the results. It's a really interesting thing, the fact that it came together at all. Yes, it's not necessarily sufficient for what we need to use today, and maybe not necessarily even was at the time. But to have all these different parties with very different interests come together and say, look, this is what we're going to agree on, is a really big thing. It's very rare that you get the entire globe coming together to say, all right, what should we do? And the fact that we're getting closer and closer to this question needing to be answered again is going to be one that all of you need to be a part of that conversation as well. How do we have all of these different cultures that live on the same planet at the same time consider how we're going to use this infinitely sized literal space?
The societal impact,
Yeah.
basically, yeah.
Actually, it was interesting because I was reading a little bit before this talk, and that treaty was one of the things that I came across. And one of the quotes from the treaty is that the exploration of space is for the benefit to be carried out for the good of all people. And I thought that was just an interesting quote to bring up out of curiosity to see whether you think this is the direction we're going with space technology and whether it really is for the benefit of all people.
Well, one thing, as well as, I actually think that there's two sort of like main reasons why we're trying to go out there and explore. And of course, beyond the science and research and exploration for exploration's sake, one really is backing up the biosphere. So meaning that we have one planet right now, and we don't really know what's going to happen, within the next few years of where we're taking it, especially, the way that we're dealing with our own climate and our own environment right now. So you need to have like some kind of a plan B. So which is still, again, for humanity. The other thing as well is that regardless of whether we solve all of our problems here on Earth, we are a finite place, and we are going to be having more people, and so therefore we would need more resources. And so all of these kind of missions or thinking of going out to mine and so forth, both have like they have business kind of like opportunities, but also survivability opportunities as well, which is why I think all of the stuff that we're doing for space is really for humanity. And
I really like the second part of that in particular about the fact that if we go to Mars, for example, I think this is what you were saying. If we go to Mars, for example, we have to learn to live in the most hostile environment that we have ever come across, that we've ever physically stepped foot, or at least by then we will have. And so for me, I actually get a little bit concerned about having a backup scenario, because a lot of people say, well, why don't we just try to look after what we've got and say, let's hope that we'll have this backup solution. And I think it's hard to say that that's right or wrong. But in going to a place like Mars or the Moon, where we say, look, we're going to work out how to make a sustainable habitat for human existence, we have to literally invent a whole range of technologies and solutions that will come back to Earth and enable us to have so much more of an abundance with resources and energy and food here that we can't do now. And so it's going to really push us to excel in a whole range of areas that we simply don't have the push to do it right now.
yeah.
And we don't know what kind of human risks we'll find when we go to the Moon, when we go to Mars. In the International Space Station in low Earth orbit, close to home, we're protected from some of the radiation that's in deep space. So hopefully we don't find that rare cancers start to happen as we inhabit the Moon and Mars. And the trip is very, very dangerous. but humans have always wanted to explore new places, and so Mars is right there. Everybody can see it in the night sky, even with your bare eyes. So we've had our sights set on there for quite a while. There's a lot of technology, as you said, that needs to be developed, and maybe the moon is kind of a base where we practice living in a hostile environment, even more than we are right now in places like Antarctica and some of the other remote areas that we've set up. It's going to be fairly similar to that, except that there's vacuum outside, and you really can't go outside. It's going to be very limiting. So not only from a technology standpoint, but also from a psychology standpoint. And there's experiments that go on of keeping people in habitats for months at a time to see what it would be like and what kind of issues come up. What kind of team do they need to build to be successful on the moon and Mars? What kind of personalities do they have to mix?
And this, sorry, I feel like I'm not giving you a chance to ask the
Please.
questions.
Go ahead.
This is just really, really fun.
Yeah,
so if you guys have any
what I want.
questions as well, please chime in because I'm just loving this. The psychology side, the space psychology and psychiatry is another huge one. So there's a friend of mine who does a lot of space. He's a psychiatrist and he does a lot of space psychiatry too. So we have these amazing discussions because it goes beyond, at the moment we choose people very specifically as who we're going to have as astronauts, as the 6-ish people that we're going to put in orbit around the planet. Now, if we go to Mars, we're going to have children that are born on that planet. We can't choose the people that are going to be there, the kinds of personalities that they'll have. What happens if they grow up in a very clinical environment as opposed to living, the space station isn't really a home. So do we have to design our Martian base to be more like a home? And how do we do that? And there's a whole range of other problems that we've never actually tried to yet address. And so for me, one of the things that I'm quite interested in is that, yes, I think the commercial race to get to Mars is huge. I think getting to Mars is actually going to be quite easy compared to the challenges that we'll face when we get there and we say, how are we going to make this sustainable?
Yeah, for sure. And then, for example, somebody who actually gets born in Mars, is that a human or is that a Martian?
That's right. And what happened,
And that person would be attuned to, the gravity that's there, and of course they potentially will not be able to potentially adapt if they actually go back to Earth, and so it just it's totally fascinating to think of. Also, my worry is that all of the things that we're having problems today, either politically or even psychologically or whatever, that we'll be replicating all of those problems again, only in a much bigger scale, meaning it's no longer like nation-to-nation potential conflicts, but it's going to be like planet-to-planet potential conflicts that are the same things. It's just like kind of
on a larger scale.
in a bigger scale.
Yeah.
Well, it takes 9 months to get there. The thing is, we are Earthlings, and so we're going to have to evolve, and this is where ethics comes in. And so, we're at a time in history where we can self-evolve. And so you already see people playing with DNA in high school with CRISPR and these other technologies. And so it's going to happen where people are going to evolve to be off-planet indefinitely, and that's kind of where we're going. And so, where are the ethics in that? And when you do have humans, if you will, in different environments with different physiologies, at what point, do you call them a Martian? And that's something that they're going to have to adapt to.
Yeah.
Do you need legs in space? You know what I mean? It's just one of those things where maybe it's a great opportunity for handicapped people. And
actually.
we can get everybody included. I don't know.
That's an interesting point that came up in a discussion I was having recently. I can't remember where. And there was an interesting scenario that someone brought up of, what if it's actually better to have no legs? And all of a sudden, if you're, a person who has legs, you've actually got less of an opportunity. And so, will we see people saying, well, I really want to be an astronaut, I'm going to cut my legs off?
You see that with athletes, right? You see that with athletes now. It's like you can actually run faster in those fourths. There was a TED Talk about a woman who came out with acrylic legs one day to just say, well, I can be anything I want. I could be 4 inches taller today.
Right.
I can have fashion legs you can see through. I mean, you can imagine wanting to be an astronaut. It's a whole Gattaca thing, right? You're totally changing yourself.
So I think that for those of you who came to my talk, both of them, I guess, but particularly the first one about the humanity of space, one of the things that I've been thinking of and that I'd like to try to inspire a lot more people to think about is what it means to be human, and it doesn't necessarily mean to be an Earthling. And so when we talk about, if you're born on Mars, are you a Martian or not? For me, I hope that we still say, well, you're still a human, because there are all these characteristics that might be because, as humans, or at least my argument was that we inherently want to go out and explore. We want to understand, we want to learn, we want to seek new opportunities. And so even if you're born on Mars or let's say, a moon of Saturn, it doesn't matter because you still, if you still have these traits and you are still human.
Yeah. It's like, is it more about like the values that you actually possess? Is that the humanity, or as opposed to the physical
I think so,
attributes
yeah. I think so as well, because we, even as humans, we don't all fit into one. We don't all have 2 legs, 2 arms, like we've just been saying, right? And so, does it make you any less human or more human? I don't think that's necessarily a part of it. Yeah.
Other physiology changes too. I mean, so astronauts, like their heavier body parts go to the center of their body. Their heart moves.
Yeah.
And
they elongate.
They elongate, and the fluids go out to their fingers. I mean, it's interesting.
You might actually look like a real Martian by the time you've been there for a little while.
It's hostile and painful, actually, for astronauts to first go into space. But then I've heard that they crave going back. And so, there's a trait of an astronaut where they come back and they just drop things automatically because they're used to just leaving things in space. And so they're evolving into this environment. This is adaptability. This is a life trait, if you will, living organisms adapting.
And they've recently been able to do the experiment with twins, with identical twins, where one of them went up to space for, I believe it was 6 months, several months.
It was a whole year.
It was
a whole year. A whole year. So they've been able to do analysis of both sets of twins, the one who went to space and the one who didn't, before and after, and track physiological changes not only while the twins were on orbit, but then afterwards. So there's kind of more ethics and experiments to be done on humans where we have that control subject of the identical twin.
Part of the reason I wanted to let the conversation really flow is because I think that solutions to real-world problems are gonna come from the problems that we face at a more extreme level when we leave the planet. So thank you so much. I want to give the audience an opportunity to ask a couple of questions that are maybe more specific to what you guys are interested in. Is there anybody in the audience that has a question for the panel? This very excited person over here does.
Well, she's in space law.
Oh, great, yeah.
And
I'm not sure how. Thank you.
number 2.
I'm not sure how much you are into Netflix, but the latest season of The Expanse was quite amazing. If you should analyze the whole script, the whole situation from our today's perspective, how much you think it might be our future? Sending people out there and then competing with them for resources.
Can you explain what The Expanse is?
Yeah, so The Expanse is it's a sci-fi series of which actually is very similar to what I mentioned earlier, where here on Earth we got nations vying for power and having political problems, and The Expanse is that it's a world where we've already expanded into the solar system. You've got Martians. Basically, Mars has been resettled or settled by humans, and then you've got the asteroid belt as miners, and so they're thought of more as sort of like second level, second-class citizens. And so it's similar to what I was saying earlier before, that it's mimicking what we have here on Earth, just on a bigger scale. And I think before we get there, it would be great if we actually figure out first how we're gonna be acting and changing our societal kind of ways to make sure that we do not replicate what the problems are here when we actually do expand. So that's, it's a really great series if you haven't seen it.
It is a long time off, so I don't think we have to worry about it for a while. I know our institute, the Lunar, it's the Solar System Exploration Research Virtual Institute, we study our moon, the moons of Mars, and asteroids, and those environments for both robotic and human exploration. Especially asteroids, that's an extreme environment and very different. There's over 200 moons in our solar system. Each one is exotic and different for many reasons. So for us to be going to those locations to live a little far-fetched as Earthlings, if you will. So, but interesting.
I might say as well, so I've only watched a few episodes of The Expanse, and I've heard that I should keep watching it, because the first thing, to be honest, the asteroid mining thing was one of the first things I noticed, and I was like, if we're that advanced, why are we sending people to mine these asteroids? It's not going to happen. So it sort of turned me off. That's just a very small thing. So I think that's probably a positive thing, where we'll see automation, robotics will be taking those dangerous jobs, so hopefully we won't see humans being treated as second-class citizens out in the asteroid belt. But definitely an interesting thought experiment for sure.
Awesome. Let's take the next question over here. Yeah.
So, okay, great. So great to see Troy.
Hey, how you going?
Jeanette again. It's Helen. My name's Helen, and I'm a space law and policy person. I've literally just flown in from the airport, from Tokyo.
Okay, cool.
You should be up here, actually.
No. I'm so glad that I managed to make it to your session. So I've already tweeted you guys as space advocates, because I want to ask you a question closer to Earth, because that's something I'm trying to do, and I guess part of what you guys are doing are similar. So I work with entrepreneurs, and some are in space, some are not in space. But I want to get them involved. I want to get them engaged, because I appreciate that, when we talk about space ecosystem, it can't just be us in this room. It needs to be a much bigger platform with lots of space and non-space people. So what is your sort of sound bite, or what is your message to engage in, with young entrepreneurs? Because that's sort of my thinking of the next generation, the target audience, and particularly here, there are many potential, probably startups or entrepreneurs that may be interested in space, whilst the theme of this conference is robotics. So, love to hear your thoughts on this. Thanks.
So, sorry.
Sorry. So first of all, in order to, so we need people that aren't just scientists and astronauts and aerospace engineers. We need people that are in policy, that are in law, that understand that. And many times engineers don't understand the law. So there's a whole ecosystem around space. I think as we look to AI and with the purposes of this conference, those data analytics, those pictures that we're taking down, the folks who will actually do the image analysis and deliver the end product, that's not an aerospace engineer. That's a software engineer who's doing the image analytics. We also have constellations of satellites that we've talked about a little bit, where there are hundreds of satellites that are flying. And today, there's roomfuls of people who operate every single satellite that is on orbit right now. It's going to be impossible when you have constellations that are 600, like OneWeb, or SpaceX is talking about 7,000 satellites recently. There's no way that we would be able to have 40 times 7,000 people operating those satellites. So you need the AI and the machine learning and the big data to be able to operate those satellites, to know which ones are working just fine, which ones have an anomaly, how serious is the anomaly, where do you have to triage that. If there's 6,000 satellites that are operating just great, leave them alone. Let's work on the other 1,000 satellites. So there's, and startups as they grow, there's a lot of startups that are in Silicon Valley that I know. They're actually looking to hire people who don't come from the space industry. They want people who think differently, who come from a different background. Because space can be a little bit of an echo chamber and a little bit of a small community. So they want to bring in somebody from agriculture who has done analysis before. What do my customers need? The person who builds the satellite isn't necessarily going to be the same person who knows what a farmer needs and what's of interest to them, or what a first responder needs, or how that whole ecosystem of getting the word to the first responder, getting the picture to the first responder works. So there are so many different ways that we need to tap into everybody in order to be successful with where space is going to be going.
So for me, I want to. So I've been really interested in space for about the last 5 years now, and this question is almost exactly what's driven me to create Moonshot in the first place. because so I discovered that CubeSats were a thing, which are these little satellites you make out of these smartphone components, about the size, a little bit larger than Rubik's Cube. You can put them into space, and they can do really amazing things. Very nutshell answer. So I was in university, and there was a group of us, and we said, hey, let's build one of these things. It's great. There's high school kids building them around the world. Surely a group of electrical engineers can get together and do this. And I think I went to a conference in New South Wales, which is one of the states in Australia, and discovered that one, there's actually quite a lot of space stuff happening in Australia, but two, there was this great talk by a person who was a space lawyer. She worked for a company called Optus, which is a big telecommunications company in Australia, and she explained all these amazing things that I just hadn't thought about with space law and regulations and telecommunications access and all this sort of stuff. And so I went back to my University of Melbourne was my university, and went to the law school and said, hey, who wants to join our space program? Because we really need people to start looking into this area of law. And for a long time, the legal team on our, what we called the Melbourne Space Program, was the most active and most passionate team, even more so than the engineers and the software engineers. And so we quickly expanded from there. We had a team for marketing of people who helped communicate these complex concepts, and to break it down and to show people, look, this is why this is valuable for you. Or we had teachers or students becoming teachers that would go and run classes with high school students and start to get them engaged. And I've taken all that and put that into Moonshot, because that's where we've got our 9-phase program, which for all the way from ideas to helping people understand what technologies and problems are out there, to starting your first company, to getting your venture capital and all that sort of stuff that you need to become a successful space company. That is all in there. And so if you aren't an engineer, this is, I guess, we definitely need more kinds of engineers too, but even if you aren't an engineer, if you're interested in space, you're guaranteed to have an area where you can use your skills as a superpower, because not many people are looking at it at the moment, and it's really, really important.
We need artists. I think there's a ton of artists at NASA, so that we could put a camera on every vehicle. Data comes down in just data, ones and zeros, It takes an artist and a software developer to put that together to make something that the public is inspired by. And they can communicate complex information as well. We need people who are chefs. We don't want crumbs on our space station. So we have to design food to adapt to the environment we're going to eat it in. We don't need food just wandering into filters and getting people sick or whatever. So we need specialists in that field. So every single field that there is could be we need architects. Habitats. We need people who understand how to be human. We want to go. We don't want a sterile environment. If you're going to be some way from Earth, to me, it's scary to look back and say everything I know is in that little space, and I'm so far away I might not go back. That's going to be scary, and so you need to make the environment look as homey as possible, and so we need architects and designers and everybody.
Could I get a quick show of hands? Who's from Tallinn in Estonia? Yeah. How many people have we got? Okay, cool. So one of the things that we're going to be working on with Robotex is bringing what we call our ideator program here next year, where we start to discuss these kinds of issues. It's sort of like a meetup, but we also sort of say, look, try to use your skills in a way to start a project that we might be able to help you build it into a real space business. And so if this is something that interests you and you don't happen to be an engineer, just know that that's coming, and get in touch, because hopefully when we're doing this again next year, a few of you might be up here and talking about these kinds of issues that you've spent a year thinking about as well.
Or maybe some scriptwriter who wants to write a story that needs to have subject matter experts help them.
Like the Martians.
Maybe if I can add as well, because I really love that question, because that's the main reason why I am in New Zealand. What we're trying to do is to create space ecosystems in a space industry when there is none. And so one of the things that I was talking about earlier is that with all of these missions that are coming up kind of like in the pipeline, it's the same terrestrial things that we're trying to do here that we're trying to transport into an extreme environment that we're going to be settling like in the future. So which means that, from food to habitation to life support systems, energy, all of these things which are already things that we're working on today, which includes engineers, artists, architects, whatever. They're the same thing. So you can port whatever your specialization is here on Earth that you're working on, and just think about that as what is the analog for those space like applications that are going to be using in the future. So for us, at least in New Zealand, what we're trying to do is for capacity building, we're going same way as like what XPRIZE is doing. We're actually doing incentive challenges and work on a terrestrial problem that could be an analog for space, and then trying to get basically general entrepreneurs or students in the country to work on those problems. And so that's kind of how you catalyze space entrepreneurs and space startups, of which like we did one New Zealand challenge this year, and we've already have like a number of startups that have come from there, and so now they call themselves space entrepreneurs, where originally they were not. So I mean, those kinds of things can sort of be inspired.
Amazing. And on that note, thank you so much for sharing these things with us, and thank you, audience.
Thank you.
I think